Okay, I should be online, I suppose. Perfect. Okay, so really, I'm really sorry for this situation, for these problems I faced during this streaming. Yes, unfortunately, the time is running out completely, and I would like, yes, to do more for the on ramp, but we need to, yes, just close the on ramp as I did, and I would like to show you a little example, okay, an application, and after that, you will see on our Facebook group the challenge I would like you to to try. I mean, if you can try to do the exercise, please, if you can, send me, I mean, the solutions, and if you have done a great job, you will obtain great gadgets. Okay, like my hat or the t-shirts of the mugs. Okay, let's try to do that challenge, but after that. Now I would like to show you an example. Okay, so for okay, I have the this one, the presentation. Okay, so here we have a mass spring damper system. Okay, this is just an example. Okay, I would like to create a system for that example. Yes, as you can see here, the mass spring damper system is created from mass, of course, the spring and the damper. K and C is for the stiffness and the damping coefficient, and F is just the force which affects our system. What we want to do is, of course, divide the equation between the biggest differential variant, and the other part of the equation is all of the stuff left. Okay, so let's open up um, our Simulink. Okay, and here, okay, this is our Simulink environment. Create a blank model. Okay, so I will try to do step by step this example. So let's wait just a second for the opening of the blank sheet. Okay, it is open in the other desktop. That's okay. So this is our environment. I would like to create, as said before, a mass damper system. For that, as you know, the equation was made out of the x dot, and x dot dot. As said previously, we need to create an integrator from and we have here, maybe I need to zoom in. Okay, there's a little bit of delay, of course. Yes, not more than a delay, indeed. Okay, Okay, I zoomed quite a bit. Okay, yes, maybe we can just fit in. Okay, never mind. Okay, so I can create the two branches. The first one is called x dot, and of course the output of x dot must be naturally x. Okay, so zoom out just a little bit. Okay, now I need to create the second integer, the second integral, to create the connection between x dot and the variable x dot dot. Okay, so I created x dot and x dot dot. Okay, now zoom just a little bit out. Okay, now what I need to do, as said previously, we need to multiply, as in the unfortunately, yes, I have the presentation here and I don't remember the equation properly, so here you can see is in an easiest way. I need to multiply x with k and x dot with c, okay, and subtract them from f. After that, I have 1 over n. So let's do it again. Here we have the Simulink workspace. Now I have to add some gains. The gain for x, and it is click just to change. For instance, I can create a variable called k. Probably this k isn't on our workspace. In fact, it's red. It's like, hey, you haven't created this variable. Would you like to create it? Yes, create it. I want to create this, and I can put in a number, for instance, a value like 1. The stiffness can be 1. Create. That's okay. That's no more the red label. That's okay. So this is our gain for the x, and as we know, it's the stiffness. So I can name it, and I can flip it with the Control I, just to have a better layout. Okay, and I can connect this x with k. The solution will be, of course, x times k. And this is for x. For dot, okay, for dot, x dot is multiplied by the damping coefficient. So I can write gain again, click on it, and create a new variable called c. Of course, it's not in the workspace of MATLAB, so I need to create it, and it will be suggested. Okay, it will be suggested here. For instance, I can click for 0.5. It can be our input. Okay, so I created another variable called c. I can just flip it with Ctrl I, connect with x dot. In this way, I created the x dot times c. All of them must be subtracted from an f, okay, a force. But of course, a force is a external input, and I would like to have this input as a sort of step. Okay, so if I search for step, okay, as a source, is an input, and I call it force. No, sorry, here not appropriate. I can double click here, and I can write force is the external force. Now, from the equation, I know that the force minus c times x dot minus k times x will be displayed quite the x dot dot. I mean, we need to divide for m, but that's not a problem. So for the first part, I can just write add. Okay, double click on it. I can change here, as you see here, I can write wherever I want. Okay, so I can write the plus, minus, plus, minus, I don't know, and that's not a problem. So the list of signs will be plus for the force, minus the x dot, minus the x. Okay, so what we're gonna do here, we're gonna see plus, minus, minus here. As you see, the block changed. So the input is the plus, the x dot times c is the minus, and k times x is another minus. Okay, so the force minus that is what? Is almost x dot dot. We just need to add another gain, which is 1 over m, but m is not our variable, so I need to create it. Okay, another time. M is like, for instance, a kilogram, so just one kilogram. Okay, so it's like 1 over 1, but for us is 1 over m, the mass. So like that, with this system, I created that mass spring damper system, like that. I'll show you in this way. Okay, so from there to that, and as I said before, is 1 over m, which multiplies that stuff, like that. Okay, like that. Yes, this is just a slide. As you see here, I have f minus that stuff, and this is f, which is yes, this is a sign, but I used a step, minus yes, c times dot x dot minus k times x. But that's it. That's okay. I mean, but now I want to display our solutions with the scope. Okay, so the scope, where can I put it? If I want to know how the position of our mass is displayed, I need to create a scope, yes, just to display, and then connect it directly to x. Okay, what I'm gonna see is that if I double click here and I see the scope of this simulation, okay, here in this page, and I press for our simulation, yes, as you can see here below, there is it's compiling. Then we have a calculation. The simulation is running. Yes, as you can see, there is a sort of, yes, a curve. but it's not really clear what is happening. Why? Because our stop time here, the simulation time, is just 10 seconds. I want to have more than that, because I can't understand. And moreover, I can't understand which is the difference between the movement of the mass and the force. So I want also to display the force. So what can I do? I can just connect the scope with the force, double click on the signal of the force and call it force, external force maybe. Null force. And yes, and more than that, I can just create a stop time of, I don't know, maybe 25. And run again. Oh, sorry. Okay. Run again. Okay, we are seeing something more, but in this way, yes. Okay, 25. I can see a much more evaluation. Oh no, there's a problem because I haven't run on it. Strange, actually. It should be more precise. Okay. Yes, there is a little bit of delay because, of course, my computer. But what can we see in the scope is that, as you can see, the force is in blue, and this is a step force, okay, and the movement of the system, which is in yellow, is a sort of, yes, a curve which goes near the force in this transition, okay. In the steady state, we will see that the movement of the system will be equal to 1. I mean, the movement will be 0 and the position will be 1 because the mass will be over the force. Okay. Okay, so this is our execution. It should work. I would like to show you also for the 25 seconds, but now the time is running out. So what I'd like to do, and yes, if you can join me on the presentation, Andrea, is that yes, this is a sort of yes, a Simulink Onramp. Of course, we had some problems, and I'm sorry for that. It is my fault. And what I'd like to do is just to tell you to try the challenge I proposed you on our Facebook group. And this is it. If you want, if you have any questions, please ask me directly through a Facebook group or by mail. And this is it. In the end, at the end, if the solution are good, send me please your solutions, and of course the Simulink model you used for the challenge, and you will obtain something like that, like this gadget, or for instance this t-shirt. And this is it. So thank you very much for your time, and I would like to do more, but of course time is running out, and the situation was a little bit a problem for me, and that's okay. So see you guys, see you.